Hello once again, our most developed student. My name is Confident and welcome to the continuation of our lesson on electricity and magnetism. And to be exact, we are continuing to look at electrostatics. So we have done a couple of videos on electrostatics, and I will encourage you to grab hold of the lesson that we did on electrostatics. And this is a continuation. As I'm saying, we did polarization. That was the end of the previous lesson. And after we sketched what happens during polarization, this is where we are, the law of conservation of electric charge. So guys, before I begin, if you want to become a part of this family, this is the 24-minute lesson family. I always say it is the channel for the underdogs, those who say I'm struggling, but if you give me enough chance to go through this subject of physical science or mathematics, I can excel and get a distinction. I can rise from low marks to get high marks. But I need someone to be patient with me. This is why this channel was opened. It has you in mind. It is you whom I feel like there is a big potential that I can see in you, and I know you can achieve. Okay. So let's look at this. The law of conservation of electric charge. So what does it mean? You have to know this law. They will ask you in an exam. You need to master this law so that whenever they ask you a question, you must be able to put it down as is. It says the net charge of an isolated system remains constant during any physical process. It can be the physical process, can be touching, can be them coming in contact together. Maybe the two isolated balls touching each other with the result in electrons moving, but they must be isolated. So they're saying the net charge of an isolated system remains constant during the physical process. And then we have a formula for calculating that, where Q is equal to Q1 plus Q2 divided by 2. And Q represents the charge, and Q1, Q2 is the charge on each sphere or on each item. So we'll look at this and demonstrate it. Okay. Maybe to start with an example, let's look at this one. It says two small identical conducting spheres are suspended, you see, by suspending, they are isolating them. They are suspended on a silk thread and are free to move. So they will ask you, why are they suspended? It's because they need them to be isolated so that there cannot be any conduction, whether it's loss of electrons or gain of electrons. So a silk thread is an insulator. It does not allow electrons to move. It then says two small identical conducting spheres are suspended on a long silk thread and are free to move. Let's sketch that and see what it looks like. So you've got something like this. These are silk threads. These are my silk threads. And then in these, you've got two spheres. They are saying they are free to move. So you've got that sphere and you've got that sphere. So you've got something like this. And then, as I say, this is my ceiling here to show that I suspended this. So this is what we have. Let's call them A and B, right? And then they are free to move. So now let me make an example. Let's say this one is a positive 2 microcoulomb. This one is negative 6 microcoulombs. Let's assume these were the charges on this sphere, because they are saying conducting spheres. So if they are conducting, it means they have been charged. And then calculate the charge on the spheres when they have touched each other. So what you must understand, actually sometimes they ask you, what are you going to observe? If this is positive, this is negative, there is something you're going to observe. Remember, positive and negative attract, so they will move towards each other. That's what you're going to observe. You'll see A and B moving towards each other. So when they touch, the question is says calculate the charge on each sphere. So they're going to touch, and then after touching, this is what you're going to observe, because they're saying explain what you'll observe. But let's first do some calculations so that we can see what is going to happen. So calculate the charges on each sphere. So what you use is the previous formula, which has did. This formula says Q is Q1 plus Q2 over 2. This is what you use when you're finding the net charge on each sphere. So we are going to say here Q is equal to Q1 plus Q2 divided by 2. So the charge, this is the charge on each sphere now, is equal to, which is positive 2 microcoulombs plus, you can even leave out microcoulombs for now. You say positive 2 plus negative 6. Remember, you're adding, finding more like the average. Positive 2, now 2 minus 6, which is negative 4 over 2, which is equal to negative 2 microcoulombs. So what you have here, the answer there, let me just make it clear there. There it is. You have got negative 2. If you use a calculator there, you'll get negative 2 microcoulombs. You can even write it like this. Remember, micro, let me remind you here, micro means you multiply by 10 to the power negative 6. Remember, so it will be now negative 2 times 10 to the power negative 6. For micro, that is 10 to the power negative 6. And then you say coulombs. So this is the charge now on each sphere. So when I'm to draw this diagram, they say explain what you'll observe. So this is what you're going to observe now. The new diagram is going to be a little bit different now, because now all of them are negative. You'll have something now like this. And why are you having it like that? Remember, this charge and that charge is now what? Negative and negative. You see that now? So if they are both negative, you know, unlike charges, what do? They repel. So it's negative 2 microcoulombs, negative 2 microcoulombs. So what just happened? You can see that the 1B has what? It has excess electrons. It has excess electrons. So these electrons were, because they are more, they were donated or they were given to A. So A moved from being positive to being negative also. Why? Because it gained some electrons. Remember, so when you gain electrons, you become negative. Now, as a reminder, the positive will never have any movement, because protons, which are positive, they don't move. What is flowing is only electrons. So it's the electrons that move from more negative to more positive. Are you with me? So always remember that. So now, because of that, you will observe A and B like that. This is our B, this is our A. So what will you observe? So you're going to say, you're going to observe A and B moving away from each other. All right. Each other. So they are moving away from each other. What is the reason? Due to repulsion. All right. Due to repulsion. And then you can say like charges repel. All right. So that is that part that they wanted to bring in there. Now, the next one is the principle of charge quantization. Very important principle again. They will also ask you, and they will ask you to use the formula. It says an object has an electric charge which is the integral multiple of the elementary charge. Remember that. And the formula says Q is N times QE, where Q is the charge, N is the integer or the number of electrons, and QE is the charge of an electron, which is given by what? Negative 1,6 times 10 to the power negative 19. So this number, you'll get it in your formulas. So you look at the end of your paper, you find some formulas that will give you that number. So now let's look at a few questions that involve what we just learned, and also some of the information that you can benefit from the previous lesson. For example, look at this question. It's an activity here. It says a glass rod is charged positively by rubbing it with a silk cloth. During this process, let's demonstrate that. So you have a glass rod here. So this glass rod, what are they saying? They are saying for this rod, you are going to charge it what? You are going to charge it, is charged positively. So you must ask yourself, how did it get a positive charge? Let me make it much thicker. If you have got a rod like this, right, and they tell you that this rod has been charged positively, you must ask yourself what happened for you to charge this rod positively. So this is what they're saying. This is the positive charge on the rod. You understand? for it to charge positively, you must understand what happened. You know, to become positive, it lost electrons. So the electrons actually went out. So these are electrons that were going out, because remember, it's the electrons that are moving. So it's charged positively by wrapping it with silk. So if there was a silk cloth here, for example, this is our silk cloth, so you'll see that the silk cloth now is the one that is negative now. Why? Because the electrons were lost from the rod. So this is your rod and this is your cloth. Are you understanding? So the electrons moved from the rod to the cloth. So there is more positive here, which are protons, and there is more negative here, which are the electrons. So that is what you must always know. Now they're saying during this process, electrons are transferred from the what? Electrons are transferred from the glass rod to the silk cloth. Yes, that's what we already said. So electrons are transferred. There is the transfer here. Are you seeing that? So this is the transfer, and then electrons are transferred from the silk to the rod. We cannot say that it's the opposite, because the silk is the one that is getting more negative. And then the other one says protons are transferred. The moment you see protons being transferred, you never see protons moving. Remember, where are the protons? Protons in an atom, if you had to say this is an electrons, this is an electrons moving here in an atom, these are electrons surrounding the what? In the center, what do you have? You have the nucleus. Alright, and in the nucleus you have protons and neutrons. So the nucleus, nothing must disturb the nucleus. You cannot reach this part. So protons are stuck in there and they don't move at all. So never say protons are moving. It is only the electrons that can be moved, either through ionization, through in reactions. Remember, there is a cation, there is an anion. When ions are lost, is called a cation. That remains. When ions are gained, it is called an anion. So all those things is the electrons that are moving. Please remember, only electrons can move. The next question is two identical metal spheres on insulated stands. By the saying insulated stands carry charges. So when they might ask you, why are these stands insulated? You must always say, so that, should they ask you that, they are insulated so that they do not allow conduction, or they do not allow electrons to move. They must not allow electrons to what? To move. That's why they must be insulated. So they're saying two identical metal spheres on insulated stands carry charges of x coulomb and -5 respectively. They are brought into contact. The moment they say they are brought into contact, you're back into this story here that we did. This is the story here. They are insulated, they are hanging, and they are brought into contact. Remember what happened here? They were moving towards each other, and at the end they ended up kind of touching each other like that. Remember, so it was a positive and a negative, that they touched each other, and then this scenario happened though. After that, they repelled each other. So that's always what happens when they are brought into contact with each other and separated again. Each sphere now has a charge of what? 3 coulombs. The value of x is, so as I say in quick form, this is what you're having. You are having two spheres like this one and this one, and they told you this is -5 coulombs and this one is, so it's negative, and this one is x coulomb. We don't know whether it's negative or positive. And then now after that, they are made to touch each other. So you have this one and this one touching one another. Remember, so if this was my A and my B, this is your A and your B, and then after some time, what happens? They are separated, and when they are separated, they will share charges, and then when they share charges, there will be similar charges, and they are telling us that each sphere now has what? Positive is positive, and this is +3 coulombs, and this is +3 coulombs. It's always the same. It's either they will be both negative or both positive after charging. Depends on which one was having the excess charge. So from here, they're asking you, what is the value of X? Remember, when you see the word brought into contact, you must know there is sharing of charge, and the formula used for sharing, Q is Q1 plus Q2 over 2. Alright, so here for 1 and 2, let me use A plus B. So it's Q, the final charge, which is, now look at this, my final charge, the charge after, this is the final charge, this one, the final charge. And they told us the final charge is what? Is 3. So you say 3, do you see what I'm driving at now? So you say 3, the final charge is QA, which I don't know is X, plus QP, which is positive, they told me is -5, plus QP is -5 over what? Over 2. See that? So this is more like you're dealing now with your mathematics, how you solve for X here, to say if I give you 3 is equal to X, now plus -5 is same as -5 over 2. Now how do you solve for X? First of all, remove that fraction, you multiply by 2 on the left, multiply by 2 on the right, so that can go. So 2 times 3 on the left, it's 6 is equal to X minus 5. Now how do you remain with X? Take -5 to the other side, it's 6 plus, from negative to positive. 6 plus 5 is equal to X. What is 6 plus 5? 11 is equal to what? X. See that? So we can now conclude that therefore X is equal to 11 coulombs. So let's check our answer. There it is. Our answer is C. Are you seeing that? So these are the questions that you can find. Sometimes they will bring them not in the multiple choice, in the actual calculations, and they want you to solve that. All right, next question says an object here is positively charged if it has more. Look, and how can an object become positively charged? So you're seeing here there is an object which is positive, and then it can only be positive because what happened? It lost electrons, went out. Electrons, the negative electrons went out, and it remained with positive protons. So this is lost. When you're positive, it means you lost electrons. So an object is positively charged if it has electrons than protons? No. When you lost electrons, you cannot have more protons than you can't have more electrons than protons because you lost them. Electrons and neutrons, remember they are called neutrons, meaning they are neutral, so they don't have an impact on the charges. Protons and electrons, yes, an object would be positive because it has more positive protons than negative electrons. So the answer is that it has protons than neutrons. D, again, neutrons are not involved in the charges, so the answer there simply becomes C. All right, so next one. So this is how you analyze some of these questions. Look at this multiple choice. 4 identical balloons, each carrying a charge, are suspended from a ceiling as shown in the diagram A, B, C, D. Balloon B is negatively charged. Look at this. Balloon B is what? Let's look at this. Is negative. Balloon B. Now, if balloon B is negative, and you can see that this is attraction, they are moving towards each other. Do you see this? So which means balloon A is what? Is positive. And then what is happening to C and D? Look at C and D. It must carry same charge because they told us that these are 4 balloons, right? It must carry same charge, but look, it's being attracted towards what? Towards B. So chances are if B is negative, this one is positive, and D also has to be positive because they are moving away from each other. You understand? So these two, there is also an attraction here because it's going towards C. So it's positive, negative, positive, positive. Which answer is? It's positive. It's either this one or this one. And then negative, I don't see the negative there on, okay, oh, charge, sign of charge on A, oh, I see, on A is positive, positive, and then on C, C can be positive, yes, and positive still working, but D can't be negative. So this is the answer. The answer there becomes what? B. So that's how you analyze some of these questions. All right. Let's look at more structured questions here so that you can understand what's happening. Two identical insulated graphite coated polystyrene spheres. Insulated meaning no charge can flow. Coated polystyrene spheres are suspended from threads. The spheres are held a distance apart. The charges on the spheres P and Q are negative, so we can call it negative 2,4 nanocoulombs. Now remember, nano, if they give you micro, you say equal to times 10 to the power negative 6. Micro is negative 6. What about nano? For 9, but it's times 10 to the power negative 9. Always remember that nano is nano. Remember nano for 9, but it's negative 9. Okay, so here, what about the other one? Is plus 5,6 nanocoulombs. Very important to know the units. So the charges on spheres are negative 2,4 and positive. So this is negative, this is positive. Very important to have an idea of that. When the spheres are released, they move towards each other. Then it says, explain why spheres move towards each other when they are released. Why are they moving towards each other? Remember, unlike, let me write here, the reason is what? Unlike charges, what? Do they repel or attract? Unlike charges, they attract. That is the main thing they wanted you to remind yourself, that they are unlike charges, positive and they attract. Then the two spheres, this is the next question now. They are saying the two spheres now touch each other. So remember, there shall come a point whereby this sphere will be like this. So you'll have it like this, and you have it like that. And what is going to happen? They are going to touch each other. This is your P, this is your Q. Alright? And then they're saying, calculate the charge on each sphere after they touch each other. Guys, when you're talking about touching each other, the formula you have for touching, there is sharing of charge, which is Q1 plus what? Q2 over 2. So Q is equal to Q1, it was negative 2,4 plus what? 5,6. Then you divide by 2. Then you find the charge, the final charge, and of course, let's calculate that, which is negative 2,4 plus 5,6 over what? Over 2. It gives me 1,6. So it's positive. See, the answer was positive. So you don't just write like this. Don't just write and say 1,6. Of course, it will be nanocoulombs, but they will penalize you because we need to know, is it just show us intentionally with the charges. You need to indicate. We know that 1,6 is already positive, but indicate to us to see that positive sign. All right, so it's positive 1,6. That is the answer here when they say calculate the charge on each sphere. So after they've separated, write down the number of electrons found on sphere P after it had touched Q. So now, very important question. Now they are saying we want to know the number of electrons on sphere P. Remember the charge on sphere P, QP is equal to, we just calculated it, is 1,6, positive 1,6. Now nanocoulombs, I said from now you need to convert it, which is positive 1,6 times 10 to the power negative 9 coulombs. And the formula now you need when you're looking at the number of what? Of electrons is the formula that we used, this formula, principle of charge quantization, where N, they say there was the number of electrons. So Q is NQE. Alright, so that's what you need to use there. So you're going to say Q is equal to NQE. E is the charge of an electron. So you already know that is the charge for P. So 1,6 times 10 to the power negative 9 is equal to N times the charge of an electron. Remember, they said it was negative 1,6 But now, just since we're dealing with the number, forget about the negative. Times 10 to the power negative 19. This number you are given is a number that is given in the what? In your formula, so you don't have to stress. So how do you find now n? You just divide by both sides, by that number. You need n, so it's like here, if I had qp is equal to n qe. How will I remain with n? You just divide by qe on both sides by qe, so that, remember, opposite of multiplication is division, so that you are remaining with n. So even here, you divide by 1,6 times 10 to the power negative 19 over 1,6 times 10 to the power negative 19, so that you are left with n alone. Then you can say, therefore, n is equal to, then you can use a calculator for that. Let's use that. It's 1,6 times 10 to the power of negative 9 over divided by 1,6. You can ignore the negative, as I said, because you're dealing with number of electrons, like as a number, a physical number, like you're counting them. So you cannot say I've got minus 10 bananas if you're counting bananas. You can ignore the negative, because when the counting of objects, it has to be a positive number. So times 10 to the power of negative 19, right, equal to 1 times 10 to the power of 10. So these are the number of electrons. These are electrons. When you're counting them, it's a big number. This is 1 times 10 to the power more than is it a billion? Because this number, it's more like you've got 10 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. So here it's like you've got 10 billion, because it's 10, it's that. These are electrons, you see? It's a big number. And then, which way will the electrons move, right? From P to Q or from Q to P? And neither way. So electrons are always moving from negative to what? Electrons will move from negative to positive. So they are moving from P, which is negative, to Q, which is positive. So here, the answer is from P to Q. And then explain your answer in that. How to explain your answer? You're going to say electrons, P has excess. Remember, being negative, P has excess electrons. And you now tell us, and electrons move from the more negative, right, to the less negative. Or in this case, you can say electrons move from negative to positive, from the excess, from the sphere with excess electrons to the sphere which has got less electrons. That's how electrons are moving. All right, so that was that part. Look at the next one. As I said, it's a quick revision, also going through a few concepts that you might need. Two identical insulated spheres X and Y suspended on threads from a ceiling are held a distance m apart, shown in the diagram. Now you understand all this. Now this one is positive, that is negative. Sphere X carries a charge of that is positive, while sphere Y has an excess of 30 electrons. Oh, there it is, has an excess. That's why it's negative, because it has an excess. That's a number. It has n is 30 electrons. You see, that's the number of electrons it has. Now calculate the magnitude of what? Calculate the magnitude of charge Y. So already they've given us the formula. Q, remember, is equal to NQE, because they gave us the number of electrons, so it can help us find the charge. Now Q, which is of Y in this case, is equal to N is 30 electrons times the charge of each electron, 1,6. Now put that negative, because you want to, you see, it will give you that negative Y. 1,6 times 10 to the power negative 19. Then if you do that, use a calculator, then it can give you the answer. 30 times negative 1,6 times 10 to the power of negative 19. There it is, 4,8 times 10 to the power negative 18. Negative 4,8 times 10 to the power negative 18. So this is the charge there. Negative 4,8 times 10 power negative 18. Alright, then they give you 3 marks for that. Not bad. Next one, if the spheres are now released and they move towards each other, of course, the one is positive, one is negative, so they will attract. Then they say, give a reason why spheres X and Y move towards each other, which has explained. Unlike charges, what? Unlike charges, they what? They attract. Don't forget. So they keep on asking that question. The spheres are now allowed to touch each other. After touching, they move away from each other. That's what will happen when they touch each other. Remember the formula, Q is Q1 plus Q2 over 2. Now they say state the principle of conservation. You see now, of charge in words. That principle, we said you definitely need to know and understand the principle of conservation of what? Of charge. There it is. The net charge of an isolated system remains unchanged during the what? Any physical process. So the net charge of an isolated system remains constant during a physical process. That's where the principle of conservation of charge, and that formula is the one we will use. So now, next one says calculate the charge on each sphere after they have separated. So you see now they're allowed to touch each other. So if I'm to use that formula here to say Q is Q1 plus Q2 over 2. In this case, Q1 is X, Q2 is Y. You see that? So Q is equal to, I can just, since all of them are, but okay, let me not confuse you, but I could just ignore that negative 18 and just say, what is that? It's 4 plus 4 plus minus 4,8. I could have done that over 2 because they've got the same exponents. But so that you don't make errors in the future, I will avoid that and say, just write in full and say Q is equal to 4, which is positive, times 10 to the power negative 18 plus negative 4,8 times 10 to the power negative 18 divided by what? Divided by 2. So you've got Q is equal to, then you use a calculator for that so that you can check what it gives. So it's 4 times 10 to the power of negative 18 and then plus negative 4,8. This is 4,8. Alright, times 10 to the power of negative 18, and we divide by 2. That is negative 4 times 10 to the power negative 19. So it's negative 4 times 10 to the power negative 19 what? Coulombs. So don't forget the units. So this is the final charge on each sphere. Don't forget, it is on, calculate the charge on each sphere after they have separated. This is that charge. Alright, then you get 4 marks. So guys, this is what you expect when you start dealing with these topics. Now we've come to the end of our lesson, and you can see the next lesson that I'm going to focus on is on magnetism. So if you are interested or you are very keen on ensuring you get a distinction, this is the time to become a part of the family of the 24-minute lesson, where we cover mathematics and science, mainly physical science for you guys who are doing grade 10. And I will encourage you, if you want to become a part of the family, the best thing to do is to subscribe and ensure that you don't miss on any video. If you're not subscribed, YouTube is not going to send you anything. But look, if you're subscribed, you'll get a lot of notifications because there are lots of different grades that I cover. But you just watch out for your grade. When you see one coming for your grade, this is the time to sit down, quickly revise, and you'll start to see your marks improving in your class. Trust me. You'll start to see you understanding things that you're not understanding. You might be able to even go ahead and watch these videos before you go to your class. When you go to your class, you're already prepared. And then when your sir or your ma'am is teaching, already you are a step ahead. So what do? Become a part of our member, become a part of the family, and join us so that you can be able to benefit from this channel. Also share it with your friends, share it with your colleagues, share it with anyone you think might need help. Put it on your social media. It is a channel with you in mind. It's designed for you. I'm putting all the effort so that I ensure when you go to that exam, I want to see you getting a distinction. Don't forget, give me feedback, give me some ideas, give me some other questions, or some anything that you feel you need assistance with that I'm overlooking. You can check my Instagram handle. It's Confingwazi. That's where you will find me on Insta, Confingwazi, and then you can just drop me a message there. And then I know for now I'm not fully going through it, but I'm improving on my social media skills. All right, thank you. See you again in the next lesson on what? Magnetism. You don't want to miss this lesson. As you can see, you need to understand what magnetism involves, as well as the questions on that. Also later we are going to focus on electricity. It's a very important topic again. Electricity, and electricity. You see all this. So join me in the next lesson. Thank you.